Hello everybody. So today we are going to solve majority element 2. So before solving this problem, I will suggest you to solve majority element problem in case you didn't you solve this problem easily and efficiently. So let's understand this problem. We are given an integer array of size n and we have to find all the elements that appear 1/3 times of the size of this array. With that said, let's check which elements are majority element in our first array. So our first array was 3 2 3. So at our 0th index there is 3. So 3 is present one time. So our second element is 2, and then our third element is 3. So we can see that 3 is present two times, which is greater than 1. So we can say that 3 is a majority element. Where 2 is only present one times, it is not called a majority. Let's understand what approaches we can use to solve this problem and how we can efficiently use them. So we are given an array of 1 elements 1 2 1 3 2 1 whose size is 6. So first we have to find how many times should an element appear so it should be an majority element. So let's find it out. So length of this array is 6. So we will use our mathematics. So length of an array is 6. We have to divide it by 3. So 3 1s are 3, 3 2s are 6. So if element has to be an we can say a majority element, so it should be appear more than two times. To find that, we can simply use an count variable in which we can store, like if one appears one time, if one appear two times we will increase the counter, then if one appear three times we will increment the counter. And we can run two loops I and j. If first of all our I pointer will be on 1 and our j pointer will be on 2. Our j pointer will be very next to I pointer when we will start every loop, like we have done in two pointers. So first of all it will check if 1 is the element at I is same as the element on j. It is not. So our j pointer will be shifted to the next pointer has to be on the next position and our j pointer has to be very next to I. So we will check if 2 is equal to 1. No, we don't have to increment the count. Then we will go to 3. If I is equal to 3, no, I is 2 and which is not equal to 3. Then we have to check if 2 is equal to 2, yes, then we have to increment a counter. Then we have to check if 2 is equal to 1, no, it's not. So then we have to increment our I. So as we increment our I, we can get our I as 1. So we know that we I 1 we have already counted 1, but as we are going through the loop, this will be our disadvantage to do so. So first of all let's see if our 1 is present. After that our I pointer will be on 1 and j pointer will be on 3. 1 equal to 3, no. 1 equal to 2, no. 1 equal to 1, yes, it's. So after that we have to shift our I pointer on third spot, and as we shift our I pointer to next spot, then we can see that our j pointer should be here. So 3 equal to 2, no. 3 equal to 1, no. But this approach will be not so efficient because it will give us a big O of n square time complexity, because we have to iterate every element with our both pointers. So to resolve that we can use a sliding window. So to use sliding window we have to first sort the array, and if we have to sort the array we will take a time complexity of n log n, and which will be more efficient than our earlier solution. So we have, after sorting our array will look like this: 1 1 1 2 2 3. And we can use our sliding window size, which will be more than one third of the size of an array. As we can see in this sliding window, we will take first three elements, and if all three elements are equal, then we will append that element to our stack or something, whatever we will take to return our solution. So in this second array, we are all elements are not equal, so we will not return anything. In our third array, all elements are not equal, we will not return anything. In our fourth array, all elements are not equal, like sliding window, are all elements are not equal, so we will not return nothing. So only majority element in this array is 1, because it is present more than 2 times, it is present 3 times. So with that said, we can also use this, but while using this we will use much of the memory, and we don't have to do that. We have to give our solution time efficient as well as memory efficient. So if we have to do so, what we can do is we will iterate this array only one time, and we already have a function in Python with array.count. So if we use that array function, we can say that if I is on 1, and it will check how many times that element is present in the array. So first of all, as it's on 1, so it will check how many times the element is present in an array. So it is all present 3 times. So if 3 is greater than the length of an array divided by 3, so yes it is, so we can return 1. And we will count how many times 2 is present in our array. So 2 is present 2 times, which is not greater than 2 times, so it is not a majority element. And we can do same with all the remaining elements, and we can finally return our output. So let's see our solution. So we have taken an array of res, where we will append our majority element. So for I in set nums, basically if we use set as we have done uh, our our approach, like we can see 1 is present 2 times in our array, so we can return that 1 2 times in our res. But to avoid that, we will use set, and set does not allow the duplicate values. So to do that, we have declare our set nums. So as we have declare our set nums, so we will be going through the iterating through the nums, and we will find which element is present how many times. So nums.count will count how many elements are there in our, like, in how many times that element is present in our array. So if nums.count is greater than the length of nums double divided by 2, which means the one third of the length of an array, so we have to append that into res, and at the end of the day we have to return. We will run this solution on Leetcode, and let's see. As we run this solution, we can see all our 3 test cases are going to pass, and if we submit, we can see our algorithm is way better than 81% of users. And in memory, we also have beated 84% of the submission that has been done through this. So thank you.